Okay, so in this video, I'll guide you through the installation process of the ARGoS blockchain interface. And the ARGoS blockchain interface is a framework for connecting the robot swarm simulator ARGoS to the Ethereum blockchain software. So the robot swarm simulator ARGoS basically looks like that. So you can set up an environment there and you can conduct experiments with a swarm of robots. And Ethereum is a blockchain framework where you can run smart contracts. And a smart contract is basically programming code executed via blockchain technology. And this makes the execution of this programming code very secure because the consensus protocol of the blockchain framework makes it very hard to manipulate the code. And in our setup here, each of the robots in the swarm acts as a blockchain node, and then the smart contract, the Ethereum smart contract, acts as a meta controller and can aggregate the information of the single robots and can send high-level commands to them. And this makes the swarm behavior robust against the presence of maybe malicious or malfunctioning robots that might send wrong information. And I don't want to go into too much detail here because all of this is explained in more detail in this article here. But now let's start with the actual installation. So I'm here on a virtual machine running Ubuntu 20.04. So due to the virtual machine, everything in this video is maybe a bit slower than on your computer. But yeah, I think it will fit the purpose. So far, it's really a blank operating system. So I've just finished the installation of Ubuntu and have not done anything else. And for the installation of the ARGoS blockchain interface, I will just follow this report here that I will link in the description of the video. So everything is explained in the report, but maybe the video helps to clarify some points. And the actual installation process is given in section 4 here. So first of all, we need sufficient disk space that I have here. We need a Docker, and we need ARGoS and the ARGoS-epuck plugin. So I will start with the installation of Docker. The installation of the Docker engine is described here. Okay, so now I will just briefly follow this guide. So I will start here. I will open a terminal and just run all the commands that are given here. Okay, so now I need to verify if the fingerprint corresponds to this one, and that looks fine. And now I will continue the installation. Okay, this will take some time, I think, so I might speed up the video a bit. Okay, so the installation finished, and I will verify that everything worked fine by running the Hello World image. And yeah, hello from Docker. So this worked fine, and we have Docker on our operating system. Now I will go to the next point in the report. That's here. So it says that by default, the execution of Docker commands requires root user privileges. So as you saw here, I needed to say sudo docker run hello world. If I leave out the sudo, I get a permission denied error. To make things a bit easier, I will change some settings here so that Docker can also be executed without being a root user. And now I will see if I still need to be a root user to run Docker commands. So I will say docker run hello world. And this time it works fine. So we finish that point. And additionally, if we want to restart the Docker engine, usually we also need to be a super user, but we can change that by executing this command here. Now I will copy it. Let's see. Ah yeah, here I'm missing the name. So my user on this computer here is called Volker. So in your case, just adapt it to your username. Okay, let's save it. So now I will try to restart Docker. And it does not ask me for the root password or the sudo password. So this worked fine as well. So now we need to install ARGoS and the ARGoS-epuck plugin. So first of all, I will make a directory called software and change to that directory, and then I get the source code of both repositories. And I think it's a very good idea to actually read the README files of both repositories because they describe the installation process in detail. So I will just do it very quickly here, but depending on your operating system, etc., yeah, carefully read these instructions. I think that's a good idea. And now I will install the dependencies. And again, this will take rather long, so I will speed it up. Okay, so the installation of the dependency is finished, and now I will actually build and install ARGoS. So I'm just following these commands here. Everything looks fine, and I will make it. This will take really long actually, so I will skip it. Okay, so the make process finished. Now I will make the doc. Okay, and now I can install ARGoS system-wide. And now I will check if the installation was successful. Yeah, so that does not work yet, so I think I also need this command here. So that your system knows where to find the ARGoS libraries. We'll try it again. And now it works fine. Okay, in the next point we will install the ARGoS-epuck plugin, so that we can simulate the epuck robot in ARGoS. We've already obtained the source code, so I will go to the ARGoS free epuck folder and just build it the same way we just built the ARGoS. Okay, now I will install it. And run ld config again. Great. So now we come to the core of this tutorial. So we will install the actual ARGoS blockchain interface. So we go to our software base folder, make a directory called AB interface, ARGoS blockchain interface, change to that directory, and then we need to obtain the source code from GitHub. So the ARGoS blockchain interface is composed of two modules, a blockchain module and the ARGoS module. So the blockchain module contains the Ethereum software, and the Ethereum software is run via Docker, and the ARGoS module is the C++ code that runs ARGoS and simulates the robots. And in this C++ code, we actually point to the blockchain module so that we can execute blockchain commands within ARGoS. Okay, so now I will obtain the source code for the ARGoS module. Great, and now we have these two modules in our folder. Then we will start with the installation of the blockchain module. So I will go to the blockchain module folder and here actually this is an outdated version here. So instead of going to ARGoS-Blockchain interface, you should change the directory to blockchain module. I will update it in the report. And then we get to the geth folder. And now we obtain the Ethereum source code. So from the official Ethereum repository. And we do that because this gives us more control over the Ethereum software. So we could, in theory, also run Ethereum via a Docker container, but then we need to rely on the official repository. But because we do research here, we might want to have more control so that we can change some parts of the Ethereum software. And this is what we will also do now. For example, if we customize Ethereum, we can change the size of the DAG dataset. The DAG dataset is a dataset that's required for proof of work, for mining, and that needs to be kept in memory of a miner. But it's a quite big dataset, so it's usually around 1 gigabyte. And maybe we want to simulate limited hardware, as is usually done in Swarm Robotics. And to this end, we will change this DAG dataset, and it's explained in section 6.1. So I will actually go to this custom geth folder now, and then have a look here. I go to consensus. Oops. ETH. And I will modify this file called algorithm. So we first need to change the size of the dataset. So we just change that to 20. And then, where do I put it? Maybe here. And then we need to comment out some lines. So we comment out these 3 lines here. And we also comment out these lines. All right, so we can save it, close it, and go back to the main part. So now we need to create the Ethereum image. So we go back to this folder, and now build it. We got a permission denied error here, so I will say new group Docker again. Just type it. And now it works. Okay, so the build process of the Ethereum image finished, and now I can initialize the Docker Swarm. Yep, that worked. And now we need to connect the blockchain module and the ARGoS module. And we do so by pointing towards the respective folders. So first of all, we need to point towards the ARGoS folder in the blockchain module. We do so by modifying this file. So I change that folder to, I'll actually copy it. Software. Okay. So this points now to the ARGoS folder, that is to the base folder of the source code that we have downloaded earlier. And now we need to point from the ARGoS folder to the blockchain module. So we go to, actually we are here in the ARGoS module, and now we modify this global config file. And say here that the Docker base is in the blockchain module. And this global config is important for many different changes you want to do in your experiments, but I will record a separate video for that because it's too complex to explain now. All right, so now we are almost done, and now the only thing left is that we still need to create the DAG datasets in order to mine in the Ethereum modules. So I go to the blockchain module, and then I go to local scripts, and I execute this create DAG script. Again, I got a permission denied error, so let's say this. So usually the creation of the DAG datasets takes some minutes, but because we modified the source code earlier, now it's really fast, and it should also work on, for example, a Raspberry Pi in a reasonably short time. All right, so now we finished the installation of the blockchain module. The only thing left is the installation of the ARGoS module, but this is rather easy. So we go to the folder of the ARGoS module and just compile it. Okay, great. So everything is installed correctly now, I hope. And now we can just run our first experiment. So I go to the section 5 here and just execute that code in the ARGoS module. So here in the ARGoS module, there's a folder starters that contains the starter scripts for different experiments. So for example, just a plain experiment, or an experiment with the Byzantine robots. And yeah, this folder contains all the experiments that were performed in the context of this journal article here that I've showed you earlier. But now I will go again to that folder and I open the report again. And now I will just type in this command. Or actually, I will quickly modify the global config. As I said earlier, here you can just set different parameters for the experiments. So here the visualization is turned on so that we will see what's actually going on in ARGoS. You can also turn it off by setting this variable here to none. And this consumes less CPU power then. And if you just want to run a bunch of experiments, it's better not to run the visualization. But this is fine now. But what I will actually change is a setting in one of the starter scripts. So I will modify this here. Usually it starts with 0% black cells or black tiles of the environment. And now I will just set it to 20% and save it. And now I start the actual experiment. This warning message here is not important. And if I remember correctly, now we are using 4 robots for this experiment. Ah, yeah, here, 4 tasks. And you can just change the number of robots in the global config file or in one of the starter scripts. You can see that the 4 Docker containers are running correctly. That means per robot we started 1 Docker container. Now a Bootstrap node mines the smart contract, and it waits until the smart contract is inserted into the blockchain, and then it retrieves its address and distributes it among the 4 robots. So this will take some time. It's a random process, let's say. So we don't know exactly how long it will take until the smart contract is actually included into the blockchain. All right, now we are very close, and now we just have to wait until the visualization starts. So here it is. So we have an environment with, I think, 20% black tiles. And if we press play, the actual experiment starts. So the robots move around in this environment and are estimating the percentage of white and black tiles. And here in this log, you can see the Ethereum commands that they are executing. So for example, here, robot number 2 added another peer to its blockchain because they were close enough to actually communicate with each other. So because we are here in Swarm Robotics, the robots only have local communication capabilities. And here, if this line is present, we can see that 2 robots are actually in communication range. Let me close that now and stop the experiment. And that's it for now. So In total, the installation took me now about 1 hour. I think it can be a bit faster if you are not on a virtual machine. But yeah, I think it will take some time. But now you can replicate the experiment that I described in this journal article. And I think I will record another video about the usage of the interface if you actually want to write your own code and if you want to conduct your own swarm robotics experiments. And that's it. Thank you for watching and see you soon. Bye bye.